let us begin the countdown. Everyone ready? Come on, start. So let's go to my first slide. So the difference between the electrode potentials of two electrodes when no current is drawn through the cell is often, this question is very mind boggling. Yeah, the difference between the electrode potentials of two electrodes when no current is drawn through the cell is, yes, if you have said cell EMF, correct, definitely correct. Cell EMF is correct. So you can look at the other options and find that the other useless options. So let's go to the next one. Which of the following statements is not correct about an inert electrode in a cell? I hope you know what is an inert electrode. That means an electrode which does not participate, it's not involved in that reaction at all. It's an inert electrode like platinum, palladium, nickel, etc. So let's see, not correct. Take a minute, read all the options. See, it's so evident that how can an inert electrode provide a surface for a redox reaction? Either the electrode behaves as an oxidation electrode or a reduction electrode. I mean, for an oxidation or a reduction. Yes, it cannot provide surface for both the reactions. Na? So this was an evident uh, option. Okay. Let's go to the next one. An electrochemical cell can behave as an electrolytic cell. So if you have an external EMF and an internal EMF and you're comparing both, then an electrochemical cell can behave as an electrolytic cell when, yes, what have you said? The cell EMF is it C or is it B? Any doubts? It could be either. You take a minute and then think about the option, and then we can go ahead with the answer. Yeah, the cell EMF is greater than the external EMF. That's the answer. Going on to the next one. The quantity of charge required to obtain 1 mole of aluminum from Al2O3 is, see, when you have aluminum, it's understood that Al is in the +3 oxidation state. So you will require 3 electrons, that is 3 farads, to get 1 mole of aluminum. So whatever be the question, the quantity of charge required to obtain 1 mole is 3 electrons, that is 3 farads, where you get a neutral aluminum atom. So the answer is C. Yes, running well, and the countdown is going fine, I hope, with you all. The cell constant of a conductivity cell. Have you seen this word constant? That means wherever you see the options with change, just reject it. Yeah, come on, you need not think. Remains constant for a cell. This was utterly easy. You should not get confused with any of the options here. Okay, going on to the next one. While charging the lead storage battery, what happens? You have to get, once you have used up the battery, the lead has got used up. So once you are charging it, you need to get your lead back, isn't it? When you have used up uh, your cell, your lead storage battery, then it has used up the lead sulfate, so you need it back. So what does the anode do? Replenish back the lead. So the lead sulfate anode is reduced to lead is the correct option. Okay, so that your cell is ready to work again with the lead, fine and plenty. Yes, so does it seem that these MCQs are very easy? Yeah, these are the kind of MCQs that would be expected for the board exam. So let us carry on this, great journey, and do keep tuned. Do join me for this quick session of recollection and re-revision. It will definitely help you. So let's carry on to the 7th one. This is, lambda m. All right, lambda m, not delta, it's lambda. So lambda m, the molar conductivity na. So in all the options it is lambda m. Lambda m for NaOH is equal to. So it's just maths. You want NaOH and whatever is unwanted, it's just maths. You have NH4 plus and OH minus is what you need. So from these options, pick out uh, or subtract something which does not is not required for you. So see, it's just a little bit of maths. Have you had a good look at the options? Yes. So see, NH4Cl, if I pick up, I get NH4 plus, I get OH minus. My Cl is unwanted, Na is unwanted. So I have subtracted NaCl from here. Wow, isn't it badhiya? Okay, yes, that is the correct option. You must be thinking that what to do. Yeah, I mean the options are so evident that I need not get confused about any other option. It's not that I'm just seeing it and then I hope you learn. Okay, okay. So the countdown is going on. Assertion reason. Wow, those are nice questions. So let's see. EMF, electromotor force of the cell, is the potential difference between the electrode potentials of the cathode and the anode when no current is drawn through the cell. I had a question. My question one was pertaining to this question. So obviously the assertion is right. So next, anode is kept on the right side and cathode on the left side while representing the galvanic cell. Let me teach you a trick. Come on. Let us see the word LOAN. L for left, L for loss. Anyway, take it. That is how it goes. So L for left, L for loss of electrons is oxidation, O for oxidation, A is the anode, and N is the negatively charged electrode. So lone refers to less or left, which is oxidation. So the left electrode, there is oxidation taking place, which is actually called the anode and is the negatively charged electrode. Isn't it a great hint for getting this answer? See, anode is on the left. So anode is kept on the right. So what is it? This reason is false. Assertion is true. Yes, so it is C. Okay. Next, lithium has the lowest electrode potential. So definitely it has the lowest electrode potential. If you see the electrochemical series, the EMF series, you would see that it is at the lowmost end of the table. That means it has the lowest electrode potential and it is negative. So, and they say lithium ion is the strongest oxidizing agent. Lithium ion, how can it be the strongest oxidizing agent? It doesn't want to get reduced, it wants to stay as lithium ion. So, obviously, here also the assertion is true, but reason is false. And to the last but not the least, Kohlrausch law helps us to find the molar conductivity of weak electrolytes at infinite dilution. Correct? Definitely. That is what Kohlrausch law is all about. And molar conductivity of a weak electrolyte at infinite dilution cannot be determined experimentally. If you are infinitely diluting a solution, you have increased the volume to such a great extent that it is never possible to determine it experimentally. Volume बढ़ा दिया, हाँ, तो तुम्हारा weak electrolyte तो dissociate हो गया, लेकिन वो ions खो गया वही solution में, तो कैसे निकालेंगे? So for this, assertion is correct, reason is also correct. Wow, so it is A. So I hope you enjoyed this session with me and do log in tomorrow. Do watch out tomorrow for a live streaming in the morning. Uh, on the lookout, be on the lookout. If I tell you the time, keep on, getting. अरे यार नोटिफिकेशंस ऑन कर दो भाई तो पता चल जाएगा कि कब मैं लाइव स्ट्रीमिंग कर रही हूँ. Yeah, so do if you think that you need some छोटा मोटा tips वगैरह, आ जाओ मेरे साथ मेरे live streaming में. Okay, so meet you tomorrow. Look out for the time. Let it remain a question mark. And bye bye, everyone.